Let's start with the Fibonacci sequence, a deceptively simple pattern that begins with 0 and 1. It's a sequence that has fascinated mathematicians and scientists for centuries, and its influence can be seen in various aspects of the natural world. Each new number is the sum of the two before it, a fundamental rule that governs the entire sequence. This additive property is what gives the Fibonacci sequence its unique characteristics and widespread applicability. 0, 1, 1, 2, 3, 5, 8, 13, and so on, stretching into infinity. The sequence continues to unfold, each number building upon the last, creating a never-ending chain of mathematical relationships. This sequence appears everywhere in nature, a testament to its fundamental role in the organization of the universe, from seashells to sunflowers, showcasing its prevalence in the patterns of growth and form. Now imagine laying out these numbers in a grid, a structured arrangement that will allow us to explore their relationships in a new way. A massive checkerboard, 72 rows by 72 columns, F to F72 and F to 72F, creating a substantial canvas for our numerical exploration. We'll call this the father grid, a foundational structure upon which we will build our understanding. Each cell is filled, left to right, top to bottom, methodically placing each number in its designated position, with the next Fibonacci number continuing the sequence within the confines of our grid. This grid contains 5,184 numbers, a vast collection of data points waiting to be analyzed. Each a step in the sequence's journey, a continuous progression from its humble beginnings, from simplicity to complexity, mirroring the evolution of patterns found throughout the universe. The choice of 72 isn't random, there's a specific reason behind this number. It's tied to hidden rhythms in the sequence, a connection that we will soon uncover. The father grid is a static map, a fixed representation of the Fibonacci sequence, a landscape of numbers, each with its own unique value and position. But its deeper patterns are still hidden, waiting to be revealed through further analysis. To reveal the underlying order, to truly understand the structure within, we need to add a new layer, a transformation that will bring the patterns to the surface. A way to color the numbers, to visually distinguish them and highlight their relationships, and expose the structure beneath, revealing the hidden architecture of the Fibonacci sequence. This is where our next tool comes in, a method that will allow us to see the sequence in a new light. The digital root, a powerful technique for simplifying numbers and revealing underlying patterns. By transforming this one-dimensional sequence, by taking a linear progression and giving it new form, into a two-dimensional field, we create a spatial arrangement that allows for new insights. We set the stage for uncovering profound mathematical beauty, revealing the hidden connections within this seemingly simple sequence. The father grid is our foundation, the bedrock upon which we will build our understanding of the Fibonacci sequence. A tapestry woven from a single simple rule, a testament to the power of mathematical principles. But to see its true nature, to grasp the essence of the Fibonacci sequence, we must look beyond the numbers themselves and delve into the underlying patterns and relationships. Let's bring the grid to life and witness the magic of mathematics unfold before our eyes. To unlock the father grid's secrets, to truly understand its underlying architecture, we use the digital root. It's a fundamental tool in our exploration. This is a single-digit value, elegantly found by adding a number's individual digits together until only one digit remains. It's a process of simplification, distilling a number down to its essence. For example, take the number 22. We add 2 plus 2, which equals 4. Or consider 144. We add 1 plus 4 plus 4, which equals 9. It's a simple, yet powerful technique. Every number, regardless of how astronomically large it may be, ultimately reduces to a digital root that falls within the range from 1 to 9. This creates a manageable set of values. Now we take a creative leap and assign each digital root a unique color, creating a visual code. We'll use red for 1 and a vibrant orange for 2, then yellow for 3 and so on, following the spectrum of the rainbow. This carefully chosen palette transforms otherwise abstract numbers into a compelling visual story, making patterns easier to discern. With our color key established, we create a new grid, which we call the mother grid, mirroring the same dimensions as the original father grid. Each individual cell within the mother grid is then colored according to the digital root of its corresponding Fibonacci number. Suddenly, the previously monochrome and somewhat austere father grid undergoes a remarkable transformation, becoming a vibrant mosaic of color. Patterns begin to emerge before our very eyes, swirls like miniature galaxies, stripes running in parallel like the threads of a woven tapestry, and intricate geometric shapes, all of which were hidden within the numbers all along, waiting to be revealed. The simple act of coloring father's values by their digital root-creating mother unveils a secret symmetry, a hidden language that exists just beneath the surface of the numbers. The resulting mother grid is far more than just beautiful to look at. It serves as a map, charting the deep and complex structure of the Fibonacci sequence. Color empowers us to perceive relationships that would otherwise remain invisible when looking at plain, unadorned numbers. This transformation, the shift from abstract numbers to vibrant colors, is precisely where the true magic of this process genuinely begins to unfold. The mother grid, with its colorful patterns and hidden symmetries, serves as our key, unlocking new pathways to explore the cosmic code. So let's delve deeper and see what other fascinating patterns emerge from this colorful transformation. Picture the father grid, a representation of pure, unadulterated numerical data. Imagine a vast ledger, an endless expanse of ever-growing Fibonacci numbers stretching out row after row, seemingly without end. The numbers balloon quickly, escalating at an exponential rate, their values soaring higher and higher. But their raw scale, their sheer magnitude, often hides the intricate patterns that lie dormant within. Now, enter the mother grid, a vibrant and colorful counterpart. Here, each number's digital root, transformed into a specific color, fills its corresponding position reflecting father's values. Let's observe the first few Fibonacci numbers as they undergo this transformation. 1, 1, 2, 3, 5, 8. These numbers, through the magic of digital roots, become a sequence of distinct colors. 13's digital root, derived through simple addition, is 4. 21's digital root simplifies to 3. And 34's digital root smoothly resolves to 7. The mother grid, in essence, is a translation, a transformation of numerical data into a visual language. It's a visual manuscript, meticulously revealing the hidden order and underlying structure of the father grid. Place the two grids side by side, juxtaposing them for a comparative analysis. The father represents the raw data, the unprocessed information in its most fundamental form. The mother, on the other hand, is the illuminated story, the artistic representation that brings the data to life. Colors cluster together, patterns repeat themselves, and collectively form mesmerizing structures that captivate the eye and stimulate the mind. Diagonal stripes emerge, triangles take shape, and much more. The patterns we observe are far from random occurrences. They're deeply mathematical in nature, elegantly emerging from the sequence's inherent rules and properties. This dual grid system offers us a profound insight, that reality itself is multi-layered. There's the surface, the visible layer of raw data that we readily perceive. And then there's the foundation, the bedrock of repeating, colorful, and resonant patterns that underpin everything we see. The mother grid serves as our map, guiding us as we explore and navigate the intricate cosmic code. It stands as visual proof, a testament to the fact that profound simplicity can indeed give rise to breathtaking complexity. The delicate interplay, the constant dance between chaos and order, is beautifully revealed in every single cell. The tapestry is woven, thread by thread, color by color. Now, with our map in hand, let's delve deeper and decode its intricate structure. The journey continues, ever onward into the vast unknown. As we study the mother grid, certain colors, certain digital roots, appear more often than others. Digital roots 1, 2, 4, 5, 7, and 8 appear 432 times each, while 3 and 6 appear 720 times each, and 9 is the most frequent, appearing 1152 times. This uneven distribution isn't random, it's a fundamental property of the sequence. Numbers form natural pairings, roots that add to 9, like 1 and 8, 2 and 7, 4 and 5. These pairs create visual motifs like magnetic poles in the grid. There's also a special triad 3, 6, and 9, forming a structural backbone. Their unique frequencies and positions suggest a deeper organizing principle. We're not just seeing pretty pictures, we're uncovering the statistical bones of a mathematical creature. The Fibonacci sequence, through digital roots, reveals a highly organized system with its own laws. These laws are the key to its cosmic connection. Why 72 by 72? The answer lies in the Pisano period, the cycle of repeating digital roots in the Fibonacci sequence. For digital roots, modulo 9, the cycle is exactly 24 numbers long. 72 columns means each row contains 3 full cycles of this pattern. Using the 1 to 9 digital roots 8 times, we get 72 rows cycle. This alignment creates powerful vertical and horizontal symmetry on a stable visual structure. 72 is also significant in geometry, 1/5 of a circle's 360 degrees, linked to the pentagon and the golden ratio. The grid's dimensions are tuned to the sequence's natural cycles and geometric roots. Our 72 by 72 grid is a perfect window into an infinite process. It's a unit cell, a building block for an endless lattice. The grid captures the entire genetic code of the pattern in a single, elegant snapshot. This is the foundation for everything that follows. The repeating patterns in our grid hint at a deeper three-dimensional geometry. Imagine wrapping the grid's edges to form a cylinder, then connecting top and bottom to create a torus, a donut shape. On this torus, the patterns flow endlessly, forming spirals and vortices. The torus is a fundamental shape in physics, representing closed, self-sustaining systems. The grid's diagonal lines follow precise angles, 30, 45, 60 degrees, dictated by the sequence 24-term cycle. As 360 degrees divided by 24 equals a 15-degree shift per term, these angles create geometric order, not random chaos. The grid is more than a flat design, it's a dynamic field, like a magnetic or gravitational field. Numbers curve and twist through higher dimensional space. Our two-dimensional view is just a slice of this swirling toroidal reality. The Fibonacci sequence encodes a geometric universe. The mother grid's patterns are fractal, self-similar at every scale. Zoom in or out, and the same motifs repeat, like tiles in an infinite floor. A larger grid simply repeats the 72 by 72 pattern endlessly. This is a mathematical lattice, the same principle that gives crystals their structure. The entire infinite pattern is encoded in a single grid unit. Complexity arises from simple, repeating rules. The grid's fractal nature mirrors the structure of reality itself. Crystals, snowflakes, even galaxies may be built on similar lattices. Our grid is a tangible model for a fractal universe. The smallest part reflects the whole. Now, a profound connection emerges. Our grid aligns with the E8 Lie group, a stunning 8-dimensional structure. E8, once an abstract curiosity, may hold the key to a theory of everything in physics. When projected into 2 dimensions, E8's pattern overlays perfectly onto our mother grid. The grid's frequencies, pairings, and triads mirror E8's intricate web of relationships. The high frequency of digital root 9 matches E8's central points. Pairings reflect E8's symmetries. Our grid is a 2-dimensional shadow of this 8-dimensional object. The repeating grid pattern echoes E8's infinite lattice in higher dimensions. Simple arithmetic, Fibonacci and digital roots, bridges to the deepest structures in physics. The grid is a slice of a higher dimensional crystal. This connection hints at a universe governed by elegant mathematical order. Our journey from simple numbers to the E8 structure suggests a hidden mathematical pattern beneath reality. Einstein and others sought a unified theory. The patterns we've uncovered may be a step toward that vision. The grid structure can be described by scalar field equations, used in physics to model fields like temperature or pressure. The universe itself might be a manifestation of such a field, a cosmic resonance. The Fibonacci sequence is a single note in this grand symphony. Our grid visualizes the harmonics and interference patterns of that note. At its core, reality may be pure information, mathematics taking form. The laws of physics emerge from simple, repeating rules, just as our grid does. The unity of the pattern speaks to a deep interconnectedness. Mathematics, physics, art, and consciousness as one. The answer to the universe's mysteries may be written in the timeless language of numbers.